Yes, friends, welcome once again to the class. Let's move on towards our next topic of discussion of today, that is matrices lecture 2. So we will start our discussion with diagonal matrix. We will start our discussion with diagonal matrix. So what is a diagonal matrix? Let us understand. But first of all, before understanding what is diagonal matrix, have a look at this particular matrix. Have a look at this particular matrix. Now these big size zeros, what do they mean? Okay, these big sized zeros over here and over here, what do they mean? So they mean something like this. Let me take red color so that it is visible properly. Okay, so it is something like this. Okay, 0 0 0. Okay, 0 0 0. Okay, so this is a diagonal matrix, and over here zeros are there. Okay, so 1 2 3 zeros, 1 2 3 zeros. So I can show it like this. In short, I can show it with a huge zero like this. Okay, this is a short form representation of this particular matrix. Now this is clearly a square matrix. Wow. Okay, and this is what kind of matrix? 3 cross 3 matrix. This is 3 cross 3 matrix. Okay, and it is a square matrix because number of rows and number of columns are equal. Okay, number of rows is number of rows. Let us first count the number of rows. First row, second row, third row. Okay, then let us count the number of columns. First column, second column, third column. Okay, so there are 3 rows, 1 2 3, and 3 columns, 1 2 and 3. So it is 3 cross 3 matrix. It is a square matrix. It is a square matrix and it is a 3 cross 3 matrix. Now, why is it a square matrix? We have taken a square matrix while defining diagonal matrix. While defining the term diagonal matrix, it is an essential condition that the diagonal matrix must be a square matrix. And why is it the necessary condition? For a matrix to be defined as diagonal matrix, first of all, it must be square matrix. Okay, I am repeating what I want to say. I am repeating what I want to say. What I want to say is that in order to determine whether a matrix is diagonal matrix or not, the very first condition is that the diagonal matrix must be a square matrix. Only then it will be called diagonal matrix. If it is not a square matrix, then it cannot be defined as diagonal matrix because it is it is only possible to determine the diagonal is possible only in case of square matrix. Okay, so this is a square matrix and the part which I have highlighted, this is a square matrix and the part which I have highlighted, this is the diagonal. Okay, 1 2 and 3. So this is the diagonal of this square matrix. Okay, this is the diagonal. For example, if we suppose had a horizontal matrix, suppose, okay, yeah, that is rectangular matrix. Suppose we have a rectangular matrix, something of this kind. So this is not a square matrix. Clearly, this is not a square matrix. It is a rectangular matrix. Okay, it is a rectangular matrix, horizontal rectangular matrix. Okay, now in this particular matrix, it has 1 and 2 rows, 2 rows and 3 columns, 1 2 3 columns and 2 rows. So it is 2 cross 3 matrix. Number of rows is 2 and number of columns is 3. So 2 cross 3 matrix. Okay, number of rows is 2, number of columns is 3. So 2 cross 3 matrix. Okay, let me undo some changes so that I can once again show it to you. Okay, okay, so this is the matrix. Now if we want to determine whether this matrix is diagonal matrix or not, can we determine? We cannot determine. Why? Because diagonal, how will you define diagonal in this matrix? How will you define diagonal in this particular matrix? If you say like this, it is not correct. Okay, diagonal will be defined if you mark like this or if you mark like this. These are not diagonals. Okay, or if you mark something like this, these are not diagonals. Okay, so if the matrix is not a square matrix, then diagonal cannot be defined properly in case of a rectangular matrix. And if the matrix is not a square matrix, the diagonal cannot be defined in case of rectangular matrix like this, diagonal cannot be defined. So that's why, as diagonal cannot be defined, in order to define a diagonal matrix, a square matrix is a necessary condition. In case of a rectangular matrix, diagonal cannot be determined. So, diagonal matrix. A square matrix is called diagonal matrix. Now, when will a square matrix be called as diagonal matrix? When will a square matrix be called as diagonal matrix? So, first of all, I will rewrite the matrix like this. this is clearly a 3 cross 3 square matrix. Okay, this is clearly a 3 cross 3 square matrix. A square matrix is called a diagonal matrix if all the non-diagonal elements are equal to 0. Okay, so a square matrix like this, it will be called as diagonal matrix if all the non-diagonal elements are equal to 0. So what are the non-diagonal elements? What are the non-diagonal elements? So these are the diagonal elements. These, and these. These are what? These are diagonal elements. Now what are non-diagonal elements? This is non-diagonal element. It is not a part of diagonal. This is a non-diagonal element. It is not a part of diagonal. This is also a non-diagonal element. This is also a non-diagonal element. This is also a non-diagonal element, and this is also a non-diagonal element. Okay. So if all the non-diagonal elements, what is it saying? A square matrix will be called as diagonal matrix if all the non-diagonal elements are equal to 0. Okay. So non-diagonal elements, as you can see, non-diagonal elements are equal to 0, but the diagonal elements are not equal to 0. Only the non-diagonal elements are equal to 0. So it will be called as a diagonal matrix. Now let us understand its mathematical definition. Let me erase this line from here. Okay, so let us understand its theoretical definition. Mathematical definition. Mathematically, okay, just remove this in. Okay, it is not to be written here. Mathematically, M capital, mathematically we can say that a square matrix A equal to Aij. So you can represent this capital A as Aij, where I is the row number and J is the column number. I have already told you. I is row number, J is column number. That I have already told to you in the previous lecture. So a square matrix A equal to Aij is called diagonal matrix. It will be called as diagonal matrix if Aij is equal to 0. Now what does it mean by Aij equal to 0? And this symbol, the meaning of this symbol is for all. Okay, for all. The meaning of this particular symbol is for all. Keep that in mind. That meaning of this particular symbol is for all. Okay, so Aij equal to 0 for all I not equal to j. Now what does this actually mean? So let me tell you that this particular element, okay, just have a look at this matrix. Okay, so it will be A11, A12. If you want to represent this matrix in terms of the Aij, okay, so in terms of Aij, how will you represent A11, A12, A13? Okay, then A21, A22, A23. Okay, then A31, A32 and A33. Okay, so hopefully you got this. So what does it mean? This is the first row. Okay, I represents row number. So this is the first row. So A11, A12, A13. Okay, A11 is this element, A12 is this element, A13 is this element, and over here 1 and 1 are there because this is the first row. Only column is changing from going from here to here. Column is changing. So 1 is changed to 2 and 2 is changed to 3. Okay, so I, that is the initial subscript, denotes row number, and later on subscript, next subscript. First subscript denotes row number and next subscript denotes column number. So this is the first row and first column, element of first row and first column. So A11, element of first row but second column. So A12, element of first row but third column. So A13, element of second row but first column. So A21, element of second row second column. So A22, the element of second row third column. So A23, then element of third row first column. So A31, then element of third row second column. So A32, and element of third row third column. So A33. So have a look at these elements. This element has I equal to j. Diagonal elements have I equal to j. This also has I equal to j. This also has I equal to j. Okay. So wherever I is equal to j, wherever I is equal to j, that element is not equal to 0. So these elements are not equal to 0. But wherever I is not equal to j, over here 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 I is not equal to j. So in these things it will be 0, this element will be 0, this 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 will be 0. Why? Because I is not equal to j in them. So for all I is not equal to j, aij equal to 0. And as soon as I is equal to j happens, as soon as I equal to j happens, it becomes a diagonal element, and diagonal element is not 0. Okay, diagonal element is not equal to 0. It can be anything but not 0. So such a matrix is called as a diagonal matrix. Such a matrix is called as a diagonal matrix. You can have a look in the figure. I also taught you the mathematical expression. I also taught you the mathematical expression for this diagonal matrix. Okay, so hopefully you have understood. Thank you very much.